So today we will be doing a problem to calculate center of mass. So the question is, a disk of radius r is removed from a disk of radius 2r. Find the center of mass of disk with a hole. So as per the question, you have a disk of radius 2r. So this is a disk with radius 2r. And from that disk, a small disk of radius small r is being removed, and we have to calculate the center of mass of this disk with a hole. So you have to find the center of mass of this shaded portion. So that is the question. Now for doing this, I am considering these two I'm considering this as two objects. One is the shaded portion and the second one is this removed hole. So I am doing this using the basic approach that we know the formula to find the x coordinate center of mass. The formula is m1x1 plus m2x2 divided by m1 plus m2. So this is the general formula to find the center of mass. And here in this question, I am considering this bigger circle with a hole as the first particle with a mass m1, and this removed portion as the second particle with a mass m2. Okay, so m1 is actually mass of disk 2r radius. M2 is actually mass of disk with radius r. Then x1, center of mass of the disk with the hole. That is what we need to find. Center of mass of disk with the hole. So this m1 is actually the mass of the disk with the hole. Okay. Now x2 is the center of mass of a removed disk of radius r. Which is being removed. So we have a two particle system of mass m1 and mass m2, and here we will be finding this x1 is what we need to find. So for doing that, I am assuming the center of mass of this whole system. We know for a complete circle the center of mass lies at the center. So center of mass of the whole system, when both the systems are put together, we'll get this as a whole system. So center of mass of the whole system, which will lie at the center, I'm assuming this as the origin. This as the x-axis and this as the y-axis. So the center of mass originally lies, for the whole system, the center of mass lies at the center. So which will be equal to m1x1 plus m2x2 divided by m1 plus m2. Okay, now see, we got it to be as 0. So denominator can never be 0 because it is a sum of the masses and the denominator can never be 0. So I will equate the numerator to 0. So you will get it as m1x1 plus m2x2 is equal to 0. From here I will get an equation for x1, which is x1 is equal to minus m2 by m1 into x2. This m2 x2 to the other side, and m1 will be coming to the denominator. So I'll be getting an equation like this. Okay, now what I'm going to do is I'm going to find this ratio m2 by m1 in terms of density and volume. Okay, so I will do like m2 by m1, which is equal to mass is density into volume. Okay, so I'll write mass of M2, the second portion, this mass will be equal to density into volume of this second portion. Volume of second portion divided by density into volume of the first portion. And we know the density remains the same, so I can cancel. Now what we have is the volume. So volume I can write in terms of area into thickness. Okay, so for that I will be rewriting the volume as thickness into area. Okay, so thickness into area of second portion divided by thickness into area of first portion. Okay, now here thickness is also a constant, so I'll get it as area of second portion, area of the second portion A2 by A1, and from the diagram it is clear that area of the second portion will be pi r square divided by area of the first portion will be the area of the bigger circle minus the area of the smaller circle, so it will be pi 2r square minus pi r square. So when you do the calculation, you will get this as pi r square divided by pi r square I can take outside, 4 minus 1. So I'll get it to be 1 by 3. I'll get it as 1 by 3. A2 by A1 I will get it to be as 1 by 3. Okay. Now we also have this x2. x2 is actually the center of mass of this removed portion. So the center of mass of the removed portion will lie at the center. So when you consider the whole circle, the center means it is at a distance of r from the origin towards the left. R from the origin towards the left. So I can write x2 as minus r2. So from the diagram I will get x2 is equal to minus r. It is at a distance of r from the origin towards the left. So I will get x2 is equal to minus r. Okay, now I can just directly substitute all these values to this x1 and I can find the value. So I will get it as x1 is equal to minus 1 by 3 into r. Okay, and this r is also minus, so I'll get it to be as r by 3. So I'll get x1 as r by 3. That means the center of mass of this disk with a hole lies at r by 3 towards the right from the origin. So somewhere over here we'll get the center of mass. Hope you understood this problem. Okay, thank you.